Hi and hello subscribers. So we are on our new topic for the performance of the lines. Actually this is the summary of what we have discussed on short lines, medium lines, and long lines. Okay, this is under lesson number 6, transmission and distribution, or TRADIS, and we are on performance of the lines, and this topic is called generalized constants of a transmission line. Okay, before we proceed, we have here a new, lapel, from Boya. So I have this review, on my channel. So since we have some technical difficulties when I have discussed long lines, so now hopefully we have a clear modulated voice and there's no interruptions. Okay, now let's go to business. Okay, so what I meant about summary, because if you already know the principle, of the ABCD constant, you have a easier time to analyze, to compute the VS and IS power factor and other parameters, simply because we need to have the principle of the two-port network. With the help of the two-port networks, we can have a simplified formula. And if you already know the ABCD constant, just store your ABCD constants and then you multiply it by the input or the given side, on our problem, which is VR and IR, and then you can already express VS and IS, instead of having KCL, KVL, and you need to have the circuit first and then by analysis. Now, if you already know the ABCD formula, ABCD constant rather, then you can solve VS and IS easily. Okay, so let us have a little bit of discussion. That again, as I mentioned, these formulas of the ABCD constants is based on a two-port network, which means that any four-terminal network of an input voltage and current, which is, we already know that VR and IR, and ABCD constants here are your inputs. And then these input currents and voltages can be expressed in output voltages and currents, which is your VS and IS. Or, in other words, if you do not know, this formula here, we can represent VS and IS by using this formula. But if you do not know, the formula itself, we can have a shortcut here. You just know the letters ABCD. That VR and IR, which is the output, is your VS, and VR and IR here, with which the output is also on current. Then you have these constants here, A, B, C, and D. Please take note that the ABCD here has its own formula or own formula dependent on the type of the line, which we will discuss on the next few slides. But we can have a scenario in terms of short line, and you know how to derive the A, B, and C, D on the short line. You can correlate that on the other types of the lines, but we will not go in further detail. But we need to know only what is A, B, and C, and D on a type of a line. Okay, now this is the general formula, so very easy to memorize. So what is the characteristics of these ABCD constants? These are constant of the line. Well, the ABCD constant of the line are complex numbers. That's why in every letter here, it has an arrow sign. As we have discussed many times on AC circuits, on polyphase systems, and power systems, that those are, with an arrow sign, is a vector in terms of polar form. So in this case, that are complex numbers that are so-called generalized constants of a transmission line. Okay, now what are the characteristics of the ABCD constants? And we need to know especially the units. The ABCD constants are generally complex numbers. As I have mentioned, they are in terms of polar representation, magnitude, and direction, or in terms of a complex entity of R plus JX. And then the units, when you say A and D, here, A and D, specifically, these are dimensionless, or per unit quantity. But in terms of B and C here, okay, please take note of these units. The B here is ohm and C is in moles. Okay, so it's like if you correlate this in a transmission line, if you correlate this, it's like you have ZL and Y respectively. So what is ZL? Impedance of the line in R plus JX, and admittance in terms of conductance and susceptance respectively, or G plus JBC. Okay, now another characteristic of this constant is A is equal to D. A must be equal to D as always. So if you already know A, then you already know D. And last but not the least, to check your line if it is corresponds to the two-port network principle, that A and D, if you multiply A and D and you subtract B and C constant, the answer must be in unity. That is for any given type of transmission line, which is short, medium in terms of nominal pi and nominal t, and long lines, which is the real solution or the rigorous method that we have discussed from the last module. Okay, so since we ran out of space, we will discuss the continuation of this one in terms of the ABCD constant of your short, medium, and long line. Please stay tuned. Hi and hello once again. So we are here on the determination of the ABCD constant of a certain transmission line. Okay, so let us first derive for the short line. By the way, we can correlate the formulas of the two-port network here simply because short lines is a very simple line. But when we go to long lines and other types of lines, or in terms of medium, we'll not go further to the derivation or in terms of derivation details. Okay, let us have the short lines. So we have here in terms of a per phase basis of a certain transmission line. So when you say a short line, only ZL is present. So when you say ZL, that is only R plus JX, or it means that only the series impedance is given. So we have here in terms of per phase basis, as we have discussed on short lines, that you have your VSN, your VRN, your transmission line, which is this one, and the current. The current here is very obvious that they are the same because they are connected in series. Okay, a little bit of KVL and KCL. It's very clear that to get VSN here, you need to have VRN. By the way, we stick to the reference at VRN. We stick to the reference at VRN. So it means that is VRN bar 0. So VRN plus the drop, which is IRZL, simply equal to VSN. And the current IS is simply equal to IR, definitely. And as you can see, I provided a space here. I intend to do that because we will correlate the formula of the two-port to this relationship. So IS is simply equal to IR. Okay, hence, using your two-port network formula from the last slide, okay, that your voltage at the sending end, we will make use of a per phase basis. Please take note, we will make use of the per phase basis. Although short lines can be single phase and three phase, but here it's practical to use in terms of per phase basis. VSN simply equal to, and IS, these are your output parameters, which is equal to your input parameters, your VRN, IR, VRN, and IR respectively. And please take note, you have a two-port network which we discuss an ABCD constant. So you need to have the A, you have the B, you have the C, and you have the D. And by the way, I forgot, you need to add this up. This is a 4-terminal network. So pretty obvious that we can now get A, B, C, and D using this relationship. So if we correlate this one here, okay, so we can interchange this one. can interchange this one. Ay, so sorry about that. Can interchange this one. We can interchange. Okay, now, we can interchange IR and ZL here. Okay. To this. You have your IR. Okay, I changed the pen so that we can prevent blotting. ZL, this is the same. Now, it's also the same here. You can already know your A, which is equal to D, based from the theory that we have discussed from the last slide, that here, it's very clear, this is your A, this is your B, you have your C, and you have your D, right? Although, it must have a VRN here. Pretty obvious that in a short line, there's no admittance. And admittance and the unit of this one must be in mhos, right? Mho, right? So this one is in terms of ohms. So if we correlate this formula here, it's very clear that your A must be equal to D, which is simply equal to a 1 value. Next, how can we get B? It's also clear that the B here is simply equal to ZL. And one relationship and unit must be in ohmic value. Last but not the least, you have your C, which is very clear it is 0 because there is no admittance, okay, which is in terms of ohms, okay, in terms of unit that is present on a short line. Hence, this is your ABCD constant. Just substitute it here. If you already know VR and IR, you can solve directly VS and IS respectively. So you know the input, the given, and then get the ABCD constant. Use this formula here, general formula for the two-port. You can now get VSN and IS respectively. So to check if our answer is correct, if you can still recall, no, this relationship from the last slide, no, that if we multiply A and D and subtract to B and C, the answer is 1. So it's pretty clear that 1 times 1 minus, you have your B in terms of ZL, but C is 0. So this is 0. And hence, Chipips kapatid, it is proven. And it is correct. Now, it means that what we have described here is already a correct relationship of your A, B, C, and D constants. So this is for a short line. Now, you can compare it to your medium lines and long lines later on the next few modules or next few slides, no, the relationship of your VS and IS in terms of VR and IR respectively. Okay, let us go to medium lines.